Hello everyone, you are welcome to the GMAT41's YouTube channel. In this video lesson, I'll be teaching you a very short approach of how to solve these questions you have here on the back. These questions are actually differential calculus problem, that's differentiation. Is that okay? If this is your first time of visiting the GMAT41's YouTube channel, please consider subscribing. And of course, if you are a returning officer and you have not subscribed yet, please do subscribe. Is that okay? So you get a lot of learning tips from this channel. Not to forget, please remember you can join our full learning class. To get information about that on Telegram, you can check through the comment section. Is that okay? To find out how to join us. I'd like to quickly say this. One of the most powerful tool or technique of differentiation is chain rule. And most times when questions are given, generally the questions are approached using chain rule. Whether the problem is that which has to be solved using product rule, or whether the question is one that has to be solved using quotient rule, or maybe sum and difference rule. The point is, when you start your differentiation, majorly we apply chain rule in the differentiation process. Therefore, I want to say chain rule is something you don't need to joke with. But in my next video, I am going to teach you how you go about chain rule, where we speak the whole lot of grammar, let u be equal to this or that. You know, I took some statistics from students, okay, gathered some information from them, and found out that most times the reason students usually don't like calculus is because of this, let u be equal to that. The question is, what is this u? Where did it come from? Why even saying u should be something? Anyway, we're going to solve this question. I will use what I call the major-minor differentiation concept. Very fast and easy. All you need to know is the standard derivative of functions, and once you've gotten that, the major-minor differentiation concept solves questions for you in just as fast can be. Here we've got this question. The first one is, if y is equal to bracket 3x to the power of 4 minus 2x plus 5 close bracket raised to the third power, that's raised to the power 3, obtain dy dx. Let us solve that and see how we approach it. Now we are given that y is equal to the third power of 3x raised to the power 4 minus 2x plus 5 raised to the power 3. And we are asked to find dy dx, we don't know. So how do we use the major-minor differentiation concept to solve the problem? Interestingly, this is our minor function. Is that okay? Permit me to use mn for it, minor. Of course, the power here, I call it the major. Is that okay? The power is called the major. So all I need to do is differentiate the minor, differentiate the major, and then multiply them. Is that okay? Therefore, you can simply say that dy dx is equal to... Now let us differentiate the minor and see what we're going to get. If we differentiate the minor here, coming to this, 3x raised to the power 4, differentiate it, it's going to give you 4 times 3 times x raised to the power 4 minus 1. That's going to be 12x to the power of 3. What I did is simple, use this 4 to multiply this, you get 12, then minus 1 from the power. Please, you can subscribe to our YouTube channel, like I said, and of course, to get full range of learning, you can consider joining our classes on Telegram, alright, or contact GMAT41 on the number showing on the screen to see how you can also join our physical classes if you are in Oka, especially if you are a Unit 6 student. Let us move on. Coming to this, differentiating this minus 2x, we are going to get minus 2. And then of course, if we differentiate 5, we will get 0. It's a constant, it goes off. How did I know that this is going to give us minus 2? Once again, use the power of x. In this case, it's 1. To multiply minus 2. Then go to the power and subtract 1 from it. If you do that, you're going to get 1 times minus 2, which gives you minus 2 times x raised to the power 1 minus 1. 1 minus 1 is 0. X raised to the power 0 is 1. Then 1 times the minus 2 gives us minus 2. Alright, we're done with this differentiation of the minor function. All I have to do is to differentiate from the major function now. The major function is that power 3. And so we are going to use that power 3 to differentiate that bracket completely. How do we do that? It's simple. 3 times this whole bracket. Are you following, right? Just like this whole bracket is taken as one thing. That is why chain rule will tell you let u be equal to. Don't worry, we are going to say that. If I was to use chain rule directly, we'll call this whole thing in the bracket u. So that this will just be as u raised to power 3. And then you differentiate 3 times that u raised to power 3 minus 1. Okay, doing that here, we're going to get 3 times that bracket, which is this. And then we'll subtract 1 from the power 3, and then we'll get 2. Okay, I think that is much the value we're looking for. The next is just to simplify. Alright, this bracket multiplied by this 3 times this will give us 36x to the power 3 minus 3 times 2 will give us 6. In brackets, then multiply this bracket, 3x4 minus 2x plus 5 to the power of 2. And of course, this is my answer. You know, I don't need to open up this bracket. Because of this power, this number cannot multiply this directly. And this is my answer. I've gotten my dy dx. Very fast, okay? Differentiate minor, differentiate major, get your answer. Let's look at the second question. This is solution to number 1. Solution to number 2, we have determine dy dx of y equal to ln cos 3x. Okay, we've got y equal to ln cos 3x. How do we obtain the dy dx of this term? We have options here. It's a simple one, dy dx. So we have to identify our major function and our minor function. This ln is our major function. So let me write mj. Then this whole cos 3x is our minor function. Let me write mn. But I want you to take note of something. If you come to this cos 3x, that cos 3x also contains major and minor. Does that make sense? I know you'll be wondering, what is Omaka talking about here, okay? How do we know the one that is the major function? How do we know the one that is minor function? It's a simple thing. You want to know? Just click the subscription button, okay? And then you can contact us to join our classes. It's simple. So you can learn more of this. I think I've answered maybe the question you might be thinking about. Y is equal to ln cos 3x. But again, listen to that cos 3x. Cos 3x. Cos. So cos is the major of that cos 3x. And 3x is the what? Minor of that cos 3x. As a matter of fact, let me reveal this secret to you until we deal with chain rule in our next video. Are you following, right? The minor function is what we usually take as u when dealing with chain rule. And with this knowledge, knowing that the minor function is usually taken as u, then if you are to solve using chain rule, you will no longer have problem thinking which one is u. The minor function is always our u when we prefer to use chain rule directly. So coming over to this, I'm going to take this cos 3x. In fact, let me pull it out here. Cos 3x. This is the major of that function and 3x is the minor of that function. So do you see that all in all, we have 2 minors, 2 majors. This is the overall major, ln. Cos is a major on its own. Are you following, right? But it is a minor of this whole thing. And of course, 3x is the minor. So I want us to do something here now, okay? We have minor, major of this minor. But this cos is minor of this major ln. How do we approach differentiation? Once you're able to break this thing down like that, the major-minor differentiation concept simply tells us start differentiating from, should I use the word, the least minor? Okay, the minor of the minor. To do the differentiation, the major-minor differentiation concept simply tells us to start differentiating from the minor of the minor. Remember, for what I read there, ln cos 3x. I told you that ln is the major function. Then cos 3x altogether is the minor. But this cos 3x has another minor, which is 3x, where cos is its major. So I want to talk about differentiate from the minor of the minor. It means we start differentiating from this 3x. Are you there? So we go 3x, if you differentiate it, you get 3. So I'll write it out. Times. The next thing, you differentiate cos. If you differentiate cos, you get minus sine. It's going to be minus sine of the minor it is carrying. And of course, the minor that this cos is carrying is 3x. Differentiating cos, you get minus sine. So you attach the 3x in front of it. And then next, you differentiate this major. Is that okay? So it's just a stepwise something, okay? This first, followed by the next function, followed by the next one. And that is it. So we go. Differentiating ln, you are going to get 1 over the whole minor it is carrying in front of it. And the whole minor in front of the ln is cos 3x. Therefore, dy dx is equal to, if you multiply this, you simply get minus 3 sine 3x all over cos 3x. And of course, if you look at your option, the correct answer is option C. Minus 3 sine 3x over cos 3x. So C is the correct option. That's wonderful. And you know what? I'm going to squeeze the solution to number 3 just here. If we are to use chain rule directly to solve this question, we are asked to obtain the differential quotient of y equal to cot square x cubed. If you are to use chain rule, you are going to define a lot of let this be that, let the other be this. Are you following, right? But the major minor simply helps you to play around this. Now this question is the same as cot x raised to the power 3 all in bracket raised to the power 2. That's the meaning of this cot square x cubed. Are you following? This square is affecting everything that you have there. Now, how do we differentiate this? If you look at this question, it is something like this. The only difference is that this bracket here is a polynomial, and this bracket here is a trigonometric function. Are you following? But we're going to use the same pattern, where you differentiate the minor and differentiate the major. So, this is our minor. Alright, and then this power is our major. Differentiating dy dx is now going to give us, are you ready? So we're going to differentiate cot x cubed, which is the minor. But look at this, cot x cubed. So cot x cubed, that cot is major, x cubed is minor. Which simply means that inside this minor, we'll still have another minor, just like what I explained in question 2. Look at that. X cubed is the minor of this cot. Therefore, we'll differentiate, like I said, from the minor of the minor. Remember, this is the major, then cot x cubed is the minor. But that cot x cubed, listening to the pronunciation, you pronounce cot. The cot is the major, x cubed is the minor. So we start from there. Differentiating x cubed, you're going to get 3x squared. And then you now move on and differentiate cot. If you differentiate cot, you are going to get minus cosec square of whatever minor that the cot is carrying. The minor it is carrying is x cubed. Differentiating cot, you get minus cosec square. So I'm going to write that. Derivative of cot is minus cosec square of the minor it is carrying, which is x cubed. Good. I am done differentiating this term in brackets. Then times, I'm going out now to differentiate from the major. Like I said, in differentiating the major term, in the case of power this way, simply use that power to multiply the whole minor and then subtract 1 from it. That is, power rule of differentiation. So let us do this. We are going to use this power now, okay, to multiply this minor and then subtract 1 from the power like we did here. So that's going to be 2 bracket cot x to the power of 3. Then you subtract 1 from this power. If you subtract 1 from this 2, you are going to get power 1. And any term raised to power 1 is that term. Therefore, the result, dy dx of this function, cot square x cubed, is equal to, let's multiply this out. Take note that these 2 will multiply this 3x squared to give us 6. And you have negative here because this is going to multiply this function. And that's going to give us minus 6x squared. We have cosec square x cubed. and then multiply by this term, which is cot x cubed. This is wonderful. And of course, I've gotten the answer using the major-minor differentiation concept. And of course, this simply tells us that the correct option is option A. Is that okay? So I'm going to take that here. This question 2 is option C. Question number 2 and 3 are unisic past questions like you see here on the board. So, great Zikites, you can always contact us to join our tutorials. We've got wonderful things for you. Not only mathematics, but physics, chemistry, okay? You can always count on the GMAS 41 as we deliver these courses for you, as well as circuit theorem courses and engineering mathematics. Please subscribe to our YouTube channel so that once we release our video tips, you'll be notified. Remember to turn on the notification bell. Like I said, you can always contact us using the number showing on the screen in order to join our full range of learning classes on Telegram. Okay? You can still go to the comment section below this video to get more information on how to join our Telegram channel. There is a link to our public Telegram channel. In our next video lesson, I'm going to show you how to use chain rule to solve this same problem. But the truth is, when I do that, you prefer this because this is faster to get your answer, especially when you're seated for objective examination. I hope to see you in our next class. Share our videos to other scholars like you and encourage them to subscribe as well too.